So we need to find the inverse of this particular matrix. It's a 4 by 4. It's going to be a painful process. So there's two things we could do. We could try to find the determinant of this. That could take a little while because we need to do cofactor expansion. And then we could use that determinant along with the adjoint to get the inverse, I believe. What's probably more realistic in the test situation, I don't know. Maybe this is more realistic. There's a lot of zeros in here, so I don't think doing row operations is going to be super painful. And then hopefully we don't have to worry too much. We can kind of hopefully skirt around having to use fractions until closer to the end as well. So let's see how this goes. Let's start here. We have a leading one in row number 1, so I'm content to leave that where it is. So we could probably start by taking row 2 and subtracting 2 row 1s, and we could take row 4 and subtract row 1. Okay, so row number 1 has no change, so we can just go ahead and copy that down. Row number 2, we need to subtract 2 copies of row 1, so that should be like that. 3 take away 0, 0 take away 4, 0 take away 4, and 1 subtract 6. 1 take away 6, negative 5. 0 take away 2, and then we should have a row 2 that looks like this. There is no change to row 3. 0, 0, 1, 0. And we need to subtract 1 copy of row 1 from row 4. So 0, 0, negative 2, 1 take away 3 should be negative 2, and then 0, oh, sorry, should be negative 1, 0, 0, and 1. Okay, what do we want to do next? We do want to get a leading one here, or at least a leading number here if possible. I'm almost wondering if it's worthwhile for us to move row 3 up and then divide by 3, because we'll be working with fewer fractions that way. Because if I just blindly divide by 3 here, it's going to cause a huge cascade of fractional problems. So I think what I probably want to do is divide row 3 by 3 and then move it up into that leading one position and then do the subtraction that I need to do. It's still going to be a little bit painful, but I don't really see any easy way of working around this. The only other thing we could potentially do is just kind of, oops, I'll do this in black. We could probably just take row 2 and subtract row 3 as well. So if I know row 3 is going to be my leading one, we could do this operation now, get the 0 that we need, and then do the swap. And then again, it's just trying to prevent having to use fractions. Anyway, whenever we do stuff like this by hand, fractions are just not very fun. Okay, so this would be 3 minus 3 for 0, negative 4 take away nothing, and negative 5 minus 1. Negative 2 take away 0, 1 take away 0, 0 take away 1, and 0. I guess while we're here, we could do the division by 3 right now. So let's take row 3. Let's go ahead and divide by 3 now. So 0, 1, 0, a third, 0, 0, a third, and 0. Now, can we realistically look ahead? If I need to get another leading one in column 3, I have kind of 2 candidates for that. I have either this negative 4 or this negative 2. What I probably want to do is, again, cause the fewest number of fractions. So I think I'm probably going to take this row 4 and use that for my leading one. So what I think seems reasonable here is let's do the row 2, row 3 switch, and let's take row 4 and divide by negative 2. So this should give us 0, 1, 0, 1 third, 0, 0, 1 third, 0. And then we'll have 0, 0, negative 4, Negative 6. Oh, you know what? Let's do the division after. I'm not about that fraction game. I'm just not about it. So negative 2, 1, negative 1, 0. Let's make the fractions at the end. Okay, so with that said, we should now be able to take row 3 and add to that. No, we need to subtract, don't we? Because they have the same sign. So let's subtract 2 copies of row 4. Then let's take row 4 and divide by negative 2. So ordering is going to be important here. Okay, so that should take care of row 1 and row 2. There's no changes here. We have row 3. We need to subtract 2 copies of row 4. So negative 4 plus 4 should give us that 0 here that we're looking for. And negative 6 plus 4 would be negative 2. Negative 2 plus 2 should be 0. 1 take away 0. Negative 1 take away 0. And then 0 take away 2. So that should take care of that. And then we have 0, 0, 1, 1. Let's make sure we get our signs correct this time. A half positive and negative a half. Ooh, I still have to deal with row 1, don't we? Yeah. Okay. We should do that here. So let's do row 1 plus a copy of row 4 as well. Because I noticed that I had this 2 here. I don't want to divide by negative 2 to introduce these fractions and then have to move these fractions around. So let's do that. That's going to update this to 0. So 2 plus negative 2. 3 minus 2 is 1. 1 plus negative 1 is 0. That'll stay 0, that'll stay 0, and then 1. So we're just going to move the 1 over to here. Okay, so that should update that. So let's go ahead now and let's move row 3 into row 4. So that we have our leading one in row 3 that we're looking for. And I suppose along the way we could probably also divide this by negative 2. So maybe I'll write it something like this. So let's take row 3. Let's go ahead and divide that by negative 2. And then we'll do a row 4, row 3 swap. So no change here to row number 1. Boop, boop, boop. Should be good there. This should be no change to row 2 as well. We are going to move this one up. And then we need to move this one down and also divide by negative 2. So that'll give us our final leading one. This should be a 0. This should be a negative half, a positive half, and a 1. So yeah, so this is where we can start to see some of those fractions starting to form over here on the right-hand side. I know, Plaisant, doing 4x4 matrices by hand, not fun. Super not fun. But at least we've kind of prevented these fractions, and the numbers on the left-hand side have turned out to be rather nice. We've gotten kind of lucky here. So now I can use this last leading one to do some cancellations, and it's fairly straightforward operation. So row 1, take away row 4. We're going to need row 3, take away row 4. And we're going to need row 2, take away a third of row 4. This is going to be the only one here that's going to be a little bit painful to do, this fractional removal. But hopefully everything goes decently well. So let's look at row 1 first. Let's subtract our row 4 from it. So 0. This will be positive a half, negative a half, and then 1 take away 1 is 0. Do I want to do row 2? Okay, I guess I'll do row 2. Okay, so 0 take away a third of 0. 0 plus 1/6 is what we get here. 0 plus 1/6. This is going to be 1/3 take away 1/6. What is 1/3 take away 1/6? I think that's just a sixth, right? And then 0 take away 1/3. Next up, we have 1/2 take away 0, so that's just going to remain at 1/2. And then, so we just get a swap of signs here. So this should become a positive 1/2 and negative 1/2. And then we get negative 1/2 take away 2 more halves. So negative 3 halves, I believe, should go here. And then our row 4 doesn't have any change. So we'll just copy that down as is, and we'll double check our answer and see how we do. So if we've done this correctly, then this 4x4 matrix should be our A inverse, right? We've been able to get reduced or echelon form on the left-hand side, so we can just maybe double check and see if that is true. Looks good to me. So I think we did some good row operations today. Sweet. Okay, I'm happy with that.